Good morning, my beloved learners. Welcome back again on our second lesson of integration. Then you remember that the first lesson, we were dealing with the indefinite integral. Then now, today, we will be continuing with the second part of it, which will be our definite integrals. Then we're here. Our main outcomes are very simple and very few. One, we shall be looking on how to evaluate or determine the definite integrals. Secondly, we shall be looking on the application of the rules to determine the magnitude or the size of an area, where this area can be either included by the curve and the x-axis, or it is between the curve, the x-axis, and the ordinates, which is x is equal to a and x is equal to b, where now our values of a and b are element of integers. Then those are our outcomes for this lesson. Then now, if we are to look on what is a definite integral, we can define it as an integral where the range over which the integral has to be calculated is given. Then where now it will be between the range of a and b, and where now on this range, your value of a must be greater than the value of b. Your value of a must be greater than b. Then how now we need to understand the notations that are used on definite integral. Then where the first thing to show that now is an integral, it should be shown by this symbol which looks like an S. Then so one can say this is a very funny S. Then we call it now is an integral sign. But where on that integral sign, we have got our limits of integration, wherein we have got that value of a, which shows your lower limit of integration, and we have got our value of b, which is our upper limit of integration. But then now, what is to be integrated? There must be a function, which is f of x, which is the function which is to be integrated, wherein now from the lesson that we have learned from the indefinite integral, we call it now as an integrand. But then where this can be integrated in terms of a variable, then where in our case here, our variable of integration is x. But please remember, like we said earlier from our previous lesson, that our variable of integration, it will not always be x. Any variable can be used. We can use the variable t, we can use the variable p or m, or any variable. Please don't always memorize that now. We can use the variable x, okay? Then besides those variables, the other important thing is check your range of the limits, which is your a and b. What is it now? When you find the value for the integral, firstly, you must determine the integral before you do any substitution of your a and b. Firstly, determine your integral using the rules that we have learned from the previous lesson. Then, if just to continue again, we can say, okay, a definite integral results in a number. If maybe you are to compare the definite integral with indefinite integral. Remember, with indefinite integral, always then your integral will end up with an arbitrary constant, which can either be k or c. But in this case, if ever you are dealing with the definite integrals, then your answer must result in a number. That's what makes the difference between the definite integral and indefinite integral, where now from the experience from examination or from the marking, you find that now some of the learners could not make the difference between the definite integral or indefinite. Where they're supposed to calculate the indefinite, then they are not adding c, but when they are supposed to determine or to evaluate the definite integral, they were adding c, which is vice versa of what is supposed to be done. Then therefore now learn and to differentiate between the two types of integration. Then the first thing is determine your integral function. Then from there, after determining your integral, secondly, you must plug in or you must substitute in your upper limit into your integral. After plugging in or substituting your upper limit, you must now substitute your lower limit. Then after plugging in, then now you must subtract the lower limit from the upper limit and not vice versa. Where now we call our upper limit as f of b and our lower limit as f of a. Then now the value of your integral will be your f of b minus f of a, which is substitution of your upper limit minus the substitution of your lower limit. Then, let's look at this. We said now define the integral, the definite integral. The definite integral, which is what we've shown, the notation, which denotes the difference of the value of f of x, where x is equal to a and x is equal to b. Then, while I was explaining, first thing for you to do is determine the integral. Secondly, substitute the upper limit, which is your substitution of the value of b, and then minus the value of your lower limit, which is your f of a. And that, in fact, at the end, it will give you the value of f of b minus f of a. Meaning that now, even if maybe from the beginning you made a mistake of including the arbitrary constant, but then at the end when you substitute, at the end that arbitrary constant will be eliminated. It will no longer appear. Like we can see here on our final answer here. Then we no longer have that constant c. We no longer have it if you have done it correctly. Then, like we did with the indefinite integral, now we are also going to do the very same with our definite integral. What is very key, you need to understand your rules. No, firstly, what you did in the indefinite integrals, we had the standard rules. Also here, you also need to know what are the rules that we need to apply when we are dealing with the definite integrals. Rule number one, then it's suppose you are given a multiplication by a constant. Like we're saying here, then integral of k dx, but then now try to look in this case here. Then we are not given the function. We are only given the constant k, no function there. We don't have any t of x, k of x, or whatever. We only have got the constant. In that case, if you are given a constant, then your integral will now be k, which is your constant, into the upper limit minus the lower limit. That is only if you are given a constant and no function. But then now, let us try to compare number one with number two, rule number two. Where now with rule number two, still here there is a multiplication of a constant. We have got a constant k. But on this constant k, it is multiplied by a function f of x. That's what makes the difference between the first rule and the second rule. Now, if ever your constant is multiplied by a function, here we have got two things that we are supposed to do. Firstly, we are going to factor out the constant k. After factoring it out, then now we do the formal integration process that we have learned in our first lesson. We do the normal integration process, then which will be like if you are given x to the exponent of n, then the integral of this of x to the exponent of n in terms of x, this will be your x to the exponent of n plus 1 divided by n plus 1. This is the standard rule that we need to remember, to always remember, that we are going to apply throughout. Then in rule number 2, our rule number 2, we call it a zero integral. What do we mean by the zero integral? It is called the zero integral wherein now, after we have done all the processes of substituting your upper limit and your lower limit, like maybe before we go there, when you try to compare here on this, you will find that now your lower limit is a and your upper limit is a, meaning that now in this case here, both our lower and upper limit are the same. Then definitely if the lower and the upper limit are the same, when we do the subtractions, then it means we are going to find it to be equals to 0. And wherein in actual sense, then there is no area between a and a. We can't have it because it is the same point. And if we're talking of the area, then we must measure it between 2 points. Then say from point B to C or from point A to B. But then in this case here, then it is from the same point. Then therefore now we don't have it. Then which will give you equals to 0. Then where if you have mastered your rule, then and when you are given a problem in an examination, by just merely through inspection, there won't be anything wrong if you don't do even the normal, but you can maybe also look in terms of the marks. If the mark is just only 1 or 2, then it means you don't have to do any mathematical calculations because you know the rule. Then you can just get it through inspection that now, here the answer is 0, because you know that now, if ever you are determining your integral and where the lower and the upper limit are the same, then your answer is 0. Then let's look on the next rule, of which we call it the negation or the reverse interval. When do we experience this? When do we experience this? It's if ever you find that now the value of A is less than the value of B. Remember from the beginning in the introduction, I said in a normal situation, your value of A must be greater than the value of, it must be less than, for that one. Your value of A must be less than your value of B. But then in this case here, you find that now your value of A, which is your lower limit, it's greater than your upper limit. Then now you can reverse that process in order to get an appropriate value of the area. You can reverse that process by saying, okay, instead of working with the A, which is greater than the value of B, then now you put in a negative first, and then now you swap your upper and the lower limit. That's why now, like if we look here on our given integral, we have, instead of A here, we are starting with B. And we end up our upper limit there, it's A, which is not according to the rule. Then now, to reverse that process, we must now put in the negative sign. That's why now we have negative of the lower limit of A and the upper limit of B, as expected. Remember always, it means when you are given a problem, you must always check your lower limit and your upper limit, wherein your value of A should be your lower limit and your value of B should be your upper limit. Then rule number 4, this is exactly the same as what we did with our indefinite integral, wherein now if we are given the sum or the difference of 2 functions, then now we determine the integral of separate functions. Then we don't have to waste time on that one. And then now the same applies to the decomposition. Okay, if we look at the decomposition or adding of the intervals, when does this happen? This happens in the situation where, like, here you have your graph. This is your y. This is your x. And then now you find that we have the area between this. We have got this part of the function of the graph, which is above the x-axis. And we also have this part here, which is below the x-axis. Then wherein now here we have got the first point here, which is your value of A, your value of B, and your value of C. We have got 3 points here instead of 2 points. In that case, then now we can apply the decomposition of this. Then which will be now, firstly, we find the integral between point A and point B. Then from there, we find the integral between, or the area between point B and point C. That is where now this rule applies. Wherein now your value of B must be less than C, but it must be greater than A. Now, before maybe we can start looking on the examples, firstly, I will remind you again that you need to have done the revision of all the standard integrals that we have learned in our first lesson of the indefinite integrals, where number one, it's your main, which is the integral of kx to the exponent of n in terms of d of x. It will be kx to the exponent of n plus 1, all divided by n plus 1. Then plus c, but wherein now your value of n should not be equal to -1 to avoid the situation where this becomes invalid. Because for any fraction which is divided by 0, that is mathematically wrong. Then you must always remember that. And again, if we're given the fraction, then for the fraction, always remember, try to check as to whether, try to check if ever, then your fraction, can it be converted to be in the form of 1 over x? If it can be converted in terms of 1 over x, you must always remember that the integral of 1 over x by dx, this is equals to ln x. Then just only, you don't only have to look at on the fraction. Firstly, check as to whether is your fraction, can it be written in the form of 1 over x? If it is written in the term of 1 over x, then you can apply ln of x, the logarithm of x. Then the last one, it's integral of ka to the exponent of nx. Then this should be equals to your ka to the exponent of nx divided by n ln of a. Then these are the standard rules that we have done in our previous lesson that you must always remember, and then you are going to apply them in both indefinite integrals and definite integrals. Then now let's look on the examples where we can apply these rules that I've been explaining. Rule number one, it's here we are given evaluate the definite integral of 5 with the limit of a is equals to 0 and b is equals to 1. When we try to look on this one, firstly check whether, here we've got 5. You know that now 5 is a constant. But then is this constant multiplied by the function? The answer is no. If we don't have the function, then therefore which rule do we apply? We apply the rule of saying now, then that will be the constant multiplied by, we said this should be k into b minus a. Because we don't have the function, it's only the constant. Wherein now here, your constant you are given, it's 5, and your value of b, it's 1, and your value of a, it's 0. Then therefore now your answer will be equals to 5 into 1, which is equals to 5. And then this proves what we have said earlier on the introduction, that now then the answer for the definite integral, it must always give you a number, not a function. Then let's look on at example number 2. Example number 2 is now the application, the multiplication of the constant and the function. Here we've got the constant 3 and the function x squared. Then with the limits a is equal to -1 and b is equal to 2. What do we do on that? We said if we have this -1, 2, 3x squared dx, we have got the constant multiplied by the function. Firstly, we said you factor out your constant, which is 3. Then you will remain with your function, x squared by dx. Then now, from there now, here we said we have got our limit of -1. There we have 2. Then now here, our main thing is to determine the integral of x squared by applying the rules that we have learned on indefinite integral, where now this will be equal to 3. Then if we are to apply the rule here, then your answer should give you x cubed divided by 3. And here, because now we are dealing with the definite integrals, we no longer add c. We don't add it. Then now, but now if we are to multiply 3 by x to the exponent of 3 over 3, then this will cancel each other, and then we remain only with x to the exponent of 3, which is your answer for the integral. But then now, this, we still have to apply the limits. Here it's -1, and here it's 2. Then we said now we subtract the values where we substitute the lower limit from the upper limit. Then now this is going to give you our value of our upper limit is 2. Then this is going to be 2 to the exponent of 3 minus -1 to the exponent of 3. We have substituted our upper limit and we subtract our lower limit. To the exponent of 3 will give you the value of 8 minus, but then now -1 to the exponent of 3 will give you the value of -1. Then this will be now 8 plus 1, which is equal to 9. This is how you should calculate it. Firstly, check if there's a constant, multiply the function. Then where there's a function, you apply your normal integration procedures. Then let's look at example number 3. Then of 0 integral, we said we get the 0 integral wherein if your value of a and your value of b are equal. Like in this case here, our value of a and b are all equals to 2. Then now from inspection, then you can automatically say down your value of the integral is going to be 0. But now, if say you are not sure of the inspection, okay, sorry, then we can apply the rules. Then there we are having 3 divided by x. But I said, check as to whether can you manipulate the given function into the fraction of 1 over x. Yes, this one we can change this. Then this can be changed as 3 multiplied by the integral of 1 over x dx. We have changed the fraction of 3 over x into 1 over x. Then now in this case, wherein now you know that the integral of 1 over x is equal to ln x. Then now this will be equal to 3 ln x, and where our limit are 2 and 2. Then if we are to apply the rule, then this is going to be 3 ln of 2 minus 3 ln of 2. Then where you can even use your calculator. Then if you are not really sure, then you could say that, okay, this should be 3 multiplied by your ln function, then which is going to give you 0. It's 0.79 minus 0.79, which will be giving you the value of 0. But then now, all these calculations, if you know the rule, then it will not be necessary. It will just be the waste of time. Then let's look at rule number 4. Then which is the negation or the reverse interval. Wherein now I said, we apply this only in the situation where you find your value of A is greater than your value of B, where under normal circumstances, your value of A should be less than the value of B. Then now, in this case here, 4 is greater than 2. Then therefore, to do that now, we must now introduce the negative sign, so that now we must swap the value of A and the value of B. Then now, this will be now the integral of 4, lower limit of 2, and the upper limit of 4 of the function 2 minus x. Then the normal procedure, you find firstly, evaluate the integral of 2 minus x, which will give you 2x minus x squared over 2. Then you do the substitutions. Then if you are doing the correct substitutions using your calculator, I think I will suggest or recommend that now always you must practice how to use your calculator, so that now you must do the substitution correctly, and then your answer will give you 2. Then now here we are coming to the example number 5, very interesting one. Then of which I'm going to comment again on this when you go to the areas. Then let's look at this here. Here we are to determine the integral of x to the exponent of 3 by dt, then with starting from -2 to 2. And then now, when you are doing your proper processes, integration processes, then now, if we're saying from -2 to 2, from the number line, it means here we are starting, say, at this point, which is -2, there is 0 and 2. We are now to find the integral starting from this point up to this point. And look what is going to happen. Then we are saying we need the integral of x to the exponent of 3 dt. If it is stretching between the two, then now you must split this into from -2 to 0 and from 0 to 2. You must split it. Then now from there now you determine your proper integral. Then this is going to be equals to x to the exponent of 4 over 4, starting from -2 to 0 plus the very same of x to the exponent of 4 over 4, but now starting from 0 to +2 from that set of interval. Then now when you do your calculations, your substitutions, then it will give you the value of 0. But remember, from the outcomes, we said we are going to apply the rules, wherein now in order to determine the area between the curve and the x-axis, or between the curve and the ordinates. But then now if we were to calculate the area, can we get an area of 0? If say here, like initially what I've done. Okay, in this case here, our graph is like this. From this here, we can say we have area number 1 and we have area number 2. But then if you are to compare the answer that you get here, where we said it's equal to 0, and now you compare with the graph, with the graph, it can show you that now here, we have got a definite area here of area 1 and the area 2. Then therefore it means the two do not tally. Then now, but let us leave it here. Then now we are going to show this again when we go to the graphs to show that now. Then what exactly are we supposed to do if we find to the situation wherein when you determine the integral, we get 0. But where in actual sense, then the area cannot be 0. What needs to be done? Then just hang on. Then number 6, then this is the same as what we did with the indefinite integral. The only difference is that here we are having the limits. Then if ever you are having the polynomial, we said before you do any process, firstly check if there's a fraction, can you factorize it, can you simplify that fraction? And if it's a product of factors, can you multiply the factors out? And then now, before you can find the integrand. In this case here, we've got x squared minus 9 over x minus 3. Before you do any substitution, firstly factorize this, wherein x squared minus 9 can be factored into x minus 3 plus x plus 3. Then these are your factors. Then this is divided by x minus 3, where at the end, this and this will cancel out, and then you remain only with x plus 3. It means now your function to be integrated is x plus 3. Then when you integrate it, this will be x squared over 2 plus 3x. Then you do the substitutions, which will give you the value of 27 over 2. Where I hope at this time, no one is still struggling then with the substitutions. And then, but what is very key, just as a reminder, make sure that now we start by substituting with the upper limit and we end up with the lower limit. Don't do it vice versa, where now you start with the lower limit and then you end up with the upper limit. Otherwise, you are going to have an incorrect calculations. Then the last example is involving the product of factors. Like I've indicated, before that now, you need to multiply out. Then, and you do the formal procedures. Then it could save time. I think by now you already understand this. Then after you have learned how to deal or to evaluate your definite integrals, then your second assignment now will be, how do we determine the area under the curve or the area between the curve and the ordinates? Like the type of the functions that are normally, that we are normally going to use at our level. Then expect to find the straight line, which is defined by y is equal to mx plus c, your parabola, your hyperbola, exponential, and the cubic functions. Then in all of this, what is required from you is to be able to identify the given function. Then our CAPS document says, at this level, you will not be required to draw or to sketch any graph, according to the policy. Then it means the examiner must provide you with a sketch. Your responsibility is to be able to identify what type of a sketch is this. Is it a parabolic function? Is it hyperbolic function? That is what is needed from you. Then, if ever you are required to determine the area under the curve, there are these very simple rules that you need to know. Number one, I said, study the sketch that will be provided, whether is it a parabolic function, is it a cubic function. Secondly, integrate that given function according to the standard rules that you have learned. Thirdly, substitute the upper limit, substitute the lower limit, and then now you subtract the values of the lower limit from the upper limit. That is, calculate your f of b minus f of a, and where your answer must be a number and not a function. If your answer is a function, it means somewhere, somehow you got it wrong. And other very key issue here, that you must make that now you master it in order not to lose not even a single mark. if we were to determine an area, your area must be a positive quantity. An area cannot be negative. But then now, through your calculations, somewhere, somehow, you are going to come across where you find that now the value of your integral is, after the substitution and everything, you are getting your answer to be negative. If you get negative, what does it mean? That is not to say that your area is negative, say, 9 square meters, because it is impossible to have a negative area. The negative 9 square units simply mean that now your graph is lying below the x-axis. That's just only the interpretation of that negative. Then at the end, you must draw the conclusion that now your area is equals to 9 square units, for example. Please always remember that. Then what's other notes that you need to take care? One, I've emphasized your definite integral. If you get it to be negative, this implies that now the area is below the x-axis. Then, but your area must remain positive. That one is a master. Then number two, if the answer of a diff is 0, like we have done with example number 5, it is impossible that you can find that there are those two areas, but then now which can give you 0. That simply means that now you need to could split. You need to determine the area of the first part, and you determine the area of the second part, and you add them. You add them. Then lastly, it's according to the exam guideline of 2018, page 8, sketch must be provided. Then you will never be expected to draw any sketch. Or even yourself, do not redraw the sketch. You will be wasting your time that you need to finish your exam paper. Then now, the first example here, it's if the graph of h of x is equal to negative 2x plus 1 is shown on the graph. There, like I've said, sketch must be given. If the sketch is given, what are you supposed to do? Firstly, identify what type of a sketch is this. From the function there, that tells you that now this is a straight line. Secondly, after identify the type of the function, determine the limits. Determine the limits, your lower limit and your upper limit. And from here, you can really see that now this area, it's starting from negative 2 and is ending at positive 2. Meaning your value of A is negative 2 and your value of B is 2. Then therefore now, it means if we are to determine the area, firstly is to put this information into the integral form. This must be represented as negative 2x plus 1 dx, where your minimum is negative 2 and your upper limit is 2. From the second rule says you must integrate. You must integrate this. Then this will be your negative 2 as a constant, x squared divided by 2 plus x, wherein this and this will cancel. Then you remain only with negative x squared plus x. But then this should be integrated from negative 2 and 2. Then now, after you have determined your integral, now you can subtract the lower limit from the upper limit. Then now this will be your, you can do this, negative, our lower limit here is negative 2. Then this will be negative into negative 2 all squared plus negative 2 minus the very same of negative of 2 squared plus 2, wherein this will be negative 2 squared is 4, which will be negative 4 minus 2, and minus, this will be negative 4 plus 2. Then when you do all these substitutions, oh, sorry, I made a mistake there. I couldn't say then it's not 2 but 4. then this is fine. Okay, let me just cancel this. And then it's 4 -2 -2x plus 1 dx. Then where this is going to give you negative x squared plus x, all from -2 and 4. Then which becomes negative of -4 squared plus 4, then minus into negative of -2 all squared plus into -2. And to do all this, you are getting to find that now your area will be equals to -6. If it is -6, I said, we don't have the area of, we don't have the area of a negative. Our area must always be positive. Then, therefore, your area must be equals to 6 square units. Your area must be equals to 6 square units. You ignore that negative, just showing you that now your area is below the x-axis. Then I'll try. Then number 2. Sorry. Number 2, it's you are given the sketch alongside represents the graph of the function defined by h of x. It's x into 5 plus 5x. Then like we did with the indefinite integral, where there's a product of factors, before anything, multiply it out. X is equals to, it's 5, is x into 5 plus 3x. When you multiply out, this is going to give you 5x plus 3x squared. Then from there now you must find the integral of 5x. Then this is going to give you 5x squared over 2 plus 3x cubed over 3. Then this will simplify then into 5 over 2 x squared plus x cubed. But what is our limit? From the graph here, it is showing that now it's starting from negative 1.5, is from negative 1, and it is ending at 0.5. Then because now we are done with this, from there now is the substitution, where you substitute from the upper limit into the whole function, minus the substitution of your lower limit. Well, then with some of these calculations, then I will skip. Then now when you do the substitutions, that is where I've ended up there. It is going to give you negative 3 over 4. Then, like I said earlier, negative just showing that now your graph is below, your area is below the x-axis, but the area must be positive, where your area must be 3 over 4. Then, number 3, then let me try to move to number 5, because both number 2 and 3, they are almost the same. Then now, what is the importance of this example number 5? If you remember, when we were evaluating, we have where we found that now when you got your value of the integral to be 0, what do we do there? Then now, like in this case here, we cannot accept whether now your integral is 0. Let us revise what we've done earlier there. We have this function of x to the power of 3. Our limit is negative 2 and 2 by dx. Then wherein if you are to integrate this, this will be x to the exponent of 4 over 4. And we have negative 2 and 2. And if we do the substitution, this will be 2 to the exponent of 4 minus sorry, this is over 4 minus negative 2 to the exponent of 4 over negative 2. And when you do the calculations, this is going to give you 0. But you look now on the sketch. Is it correct? Is it true that we can say the area here can be 0? No, it cannot be 0. Because you can see on the sketch here that now we have got this part. Then this part is not 0. We have got an area of this portion here. And we also have got the area of this portion. Then therefore now, this solution here cannot be accepted. If it is not accepted now, what should we do in order to consolidate these wrong calculations versus the reality, what you see here? Then now, in that case here, we must now split this function into 2. Okay, then let us move here. Then if I am to redraw this, which means I have something like this, then where at this point here it's negative 2, this is 0, and this is 2. It means now I should split this between negative 2 to 0 and 0 to 2. You must now determine the area of this part, which is from negative 2 to 0. And again, you determine the area from 0 to 2. At the end, we add them. And then let us see what's going to happen. Then, okay, this is what I've already shown that now. Okay, when we did, we are getting our area to be 0, which is not correct. But then now, if we split them, then you are going to find that now your first area is going to be 4 units. Then let us look at how are we getting this. Firstly, let's get the area between negative 2 to 0. And then there we said, this means this will be your x to the exponent of 4 over 4 dx. Oh, no. Sorry, let me delete this, sorry. This is x to the exponent of 4 over 4 to be evaluated from negative 2 to 0 as our first part. Then this will be meaning that now this will be 0 to the exponent of 4 over 4 minus negative 2 to the exponent of 4 over 4. This is going to give you 0 divided by any number is equal to 0 minus negative 2 to the exponent of 4 is 16. 16 divided by 4 is equal to 4. Therefore, we can say area number 1 is equal to 4 square units. Then, now let's look again the area of the second part, then which will be x to the exponent of 4 over 4. But then this one is to be determined from 0 to 2. Then this will be calculated as 2 to the exponent of 4 over 4 minus 0 to the exponent of 4 over 4. This will give you 2 to the exponent of 4 is 16 over 4. This is equal to 4 minus 0, which is equal to 4. Then therefore, area 2 is also equal to 4. But then now, here we need the area of the entire function. Then our conclusion will be area now will be equal to area 1 plus area 2, which will give us 4 plus 4, which is equal to 8 square units. That is very, very critical in the situation where now, when to determine the area, it's giving you 0, which is impossible. The area cannot be 0 or between the two. It means there is something wrong. Then now you must split the two. Then from there, I've given you the the practice example, because now with mathematics we simply said now, then it should be practice, practice, practice. Then for them, I've given you these practice exercises covering all the rules and probably all the functions that we are supposed to deal at our grade 12, where the first one is a straight line, and the second one will be the cubic function that you know this, but then now here, it is between 1 and a. Then you are going to do these exercises on your own. Then example number 3 is where you are given the parabolic function. Number 4 is an hyperbolic function. And, okay, then I've ended up on the parabolic function, but then always then now, it should be, what is very important, it's master all the standard rules. Secondly, you cannot deal with integration if you do not know your exponential laws. It means your exponential laws remains important. Then, if ever you are dealing with the indefinite integrals, you must add the arbitrary constant c. But if you are dealing with the definite integral, your answer must be a number. Again, if you are to calculate the area, you must always remember your area cannot be negative. It must always be a positive quantity. And lastly, you must master all the notations. Notations for those, for all, either indefinite integral and also for the definite integrals. Then my motivation is in life, in order to succeed, you must decide while others are delaying to decide. Don't wait for somebody to decide on yourself. Always have a positive mind to decide. Begin while others are still thinking, can I do it or must I not do it? Don't procrastinate any of your decisions. You must always work hard while others wish to save time. Then don't save time. Don't waste the time. Always work. Persist while others quit. What I've learned in my life is you must have that spirit of perseverance. And don't quit. Study through and through while others are sleeping. Because with maths, technical maths, then you cannot expect to get the answers without practicing. Practicing is the language of mathematics. Then this brings us to the end of everything, and I thank you so much. No riwu. Then with the words of our greatest leader, it is in your hands to create a better world for all who live in it. Be productive to the community where you are living. In the school where you are attending, please learn to assist your other colleagues so that now the greater community can achieve, not only yourself. Thank you so much.